Now next is for the what we call it, the recursions. So how to write recursive functions. There are certain problems that can be solved with recursive functions. There are also problems that can't be solved without recursive functions. So for now, we're going to see how to take a loop and turn it into something that is recursive, because recursive function, the way we write them are very similar to the way we write loops. Let's say you have something like an integer, a value n, which is equal to 5, and you want to display this value using a loop. We can easily use the while loop. We say while n is greater than 0, then we want to display the value of n. Then after that, we say n minus minus. So this is a loop that displays the values from 5 to 1. Okay, so let's run this code to see the display. What is displayed here? We have 5, 4, 3, 2, 1. Great. But now, if they ask us to create a function that does the same, we can write a functions like that, void print n. So we'll have the same kind of code inside. There is a loop, and the loop displays the values of n. So instead of using the loop in the main function, we're going to use the print n function and pass in n. Great. Let's compile this code and see what it does. Great. So it does the same thing. It displays from 5 to 1. So this is a loop we're using to display um, uh, the values. But now when they ask us to display what we call it, when we need to use recursive functions, we can turn this loop into something recursive for this function. So the condition for which the loop will stop is when n is no longer greater than 0. So the stop condition is when n is lesser or equal to 0. So it is the opposite of here. We return. That means we don't want to loop. Or we can use the same condition if n is greater than 0. If n is greater than 0, we first print. We say print it. Then we type in the value of n. Then after that, what happens? We say n minus minus. Okay. So when the loop hits the n minus minus, it will go back and check if n is greater than 0. So this is where we can place our, so we change the while loop condition into an if, Then at the end, we will call the function again. Let me comment this and execute the code to see what will happen. It does the same thing, 5, 4, 3, 2, 1. So it displays the same result as like we are in a loop. So we're calling the same function again and again, like in a loop. Um, but this time we're using the recursive way. These two are very similar because when you look at a loop, you see that the loops go back and do the check. It go back again and do the check. The same things happen here, but this time we say the stop condition is, so if n is greater than 0, so that means we can execute the contents. The same thing for the while loop. If n is greater than 0, we execute the content. Next, we print the value, the same thing as we do in the loop. Then n minus minus, the same thing again. And when the program for the while or for the while loop, when the program hits on the last instruction, it will go back and check again. So it will go back and start checking, then see if it can continue or not. So for the recursive way, this is how we tell the computer to go back and check again. So we pass in another value of n to the same function. So this function will execute, and the previous one, the previous call will be waiting for the next one. Let me draw something here for us to understand how these things work. Okay, so let's call, this is the first call, and this is the second call, and that is the third call, and so on. So when we have, I'm going to change the color to green. Great. So what happens for the first call, what happens is that the first function will check if the n is greater than 1. If the n is greater than 1, it will print, then it will do another call. So the other call, what happens, this function get executed again. Then after that, this other one will execute another call function. This other one will execute the other one. So till the conditions or the stop conditions get false, so that no other function get executed. So when that happens, um, the deepest function call will return. So now this time, this function will return, and this other one will return. Then this other one will return to the parent function, and the parent function continue its execution. Then the program end. So the recursive functions are just functions that calls themselves. A function that calls itself. This is a recursive functions. A function can call another function, but for the recursive function, when you writing this kind of function, you have to be careful so that you might not have infinite loops. For example, we can have infinite loops like here for the while loop. The same thing is valid for this. I'm going to type in a condition that doesn't make any sense, just for the purpose to create infinite loop. This condition is always true. So I'm telling that if n is greater than 0 or n is lesser or equal to 0, it is always true, so that we'll have an infinite recursion. If it takes time or if the recursions is too much, the computer might decide to stop your program. Let's do it. Let's execute the code. And here what happens, it is a loop. It doesn't terminate. So now the computer has decided to stop the program. We can create infinite loop with even the normal loops like that for the while loop. I'm going to comment the code here and add a conditions that never get false. So while n is greater than 0 or n is lesser or equal to 0, this condition is always true. So let's create another infinite loop to see what happened. We have got the same kind of issue. So, but here our program is not stopping. Why? Because the way that loops works is not the same as recursive functions works. When you call a function recursively, it will take up memory space, and each time the function calls itself, another memory space will be taken up, and so on and so on. Then later, the operating system will decide, hey, this program is not behaving well, so I'm going to stop it. But for the loops, the memory space is not taken up. Um, the, the computer just execute the instruction and go back again, execute the same instructions again and again and again, but no memory space or no more memory space is added to that. But for any function call, that will take memory spaces, that will take spaces on the stack, because when it gets deep, 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 the computer will detect and stop your program. So this is why we're here. Our program is still working, but we're going to stop it. We can even display things such arrays using recursive functions. I'm going to change these functions to something else. Let's say we want to display an array. You can say int array of 5 elements, then initiate the array to these 5 elements. Okay. So next, we want to display this array. So I'm going to create a function called print array. So it will take up an array, then it will take also the length of the array. Great. Then let's call this function inside our main function. And then we pass in the length 5. Great. We can use a loop to display the content of the array. For example, we can say if I, then we say while I is lesser than length, we display the array. Okay. So let's compile and execute this code and see what happened. GCC main.c, the output file name will be main. Then let's execute the code. Oh, sorry. We have an infinite loop because here we did not increment I, so I is always lesser than length. I'm going to add I++ and compile the code again. Okay, so I++, then we display the content of the array. Now let's try to turn these functions into a recursive function. So as we said that an array, a loop, a recursive function is very right. The way we write recursive functions is kind of similar to loops. We know the condition, the stop condition, and we also know that I must increase. But here we're going to try something else. The same things can be written like that. You can still say array plus I. So typing I with the square bracket, typing the name of the array, then access the value using the square bracket notation is the same as using the dereferencing operator, because we're saying that we want the address of the next value, then we dereference, then we display. The same strategy can be used because when you type in something like array plus 1, it's the same as typing array plus plus. We can increment the value inside the array variables, then continue to display. So let's use our recursive things. If the length is greater than 0, we're going to display the array. Okay. Then next, we say we increment we're going to call the same print array function, but this time we're going to add 1 so that we get the next address. Then we change the length. So the length, we move the pointers to the next value. Then we do length minus 1. I'm going to stop the session and start again because we are at the 40-minute limits that Zoom imposed. Let's get back.